Hello class, welcome to Big Bang Data Science Solution Ramadan program. And Salaam alaikum, good morning, good evening, good afternoon. Good afternoon, good evening. It depends on from where you are joining the program. Welcome to week number 3 of the Ramadan program. Today we are going to talk about something probably new to you. But let's go through what we covered. In week 1, session 1, we talked about the in week 1, session 1, we talked about the data science in general. We explained the motivation of data science, data explosion. We talked about why data science, why should I invest in learning data science. We talked about the types of analytics. We talked about the portfolio and the day-to-day activities of data science. Then in session 2 of week number 1, I believe Ed was the driver, and he simply went through an introduction to the foundation of R. He talked about the arithmetic, the assignment, the list, the dictionary, sets, tuple, functions, lambda, and conditions. These are a foundation of Python programming or Python for data science. And in session number 2, in week number 2, we talked about session number 2, week number 2, session 1 and 2. We talked about CRISP-DM, and in week number 2 we talked about the CRISP-DM business understanding. We talked about the data science process, the micro and macro methodology. We talked about how to quantify your business problem, how to identify the target variable, how to identify the business measurement, how to identify the stakeholders, how to start and monitor a project. Today we are going to go back a little bit to Python, and Ed will be driving, and we are going to simply talk about the in brief. It is not going to be a thorough explanation of the most common packages. So we are going to do our best to cover as much as we can. So we will talk about Numpy library, Pandas, Matplotlib, Seaborn, scikit-learn, and NLTK. Hopefully we could talk about all these libraries, but we are going to start with one at a time, and if we have to finish by 2 o'clock, and now we have to finish in 2 hours. If we don't cover all these packages within this 2 hours time frame, we might need to schedule another one. I'm not promising anything, but we will do our best to do that. But please keep the questions all the way to the end, because the more questions you ask, the more time we are gonna waste. Keep the questions all the way to the last 30 minutes, and you will have a chance to ask your questions. And tomorrow we are gonna move into data understanding. So tomorrow we are gonna have a hands-on on Python. We are gonna learn how to read data, how to start using Python. So we are going to read the data using Python, and of course we are going to look into the variables. We are going to do some statistical analysis to help us understand the data better. We are going to apply some data visualization to build some graphs to represent our data, so we can see any deficiency in the data. And also we are going to apply some EDA, which stands for exploratory data analysis. Try to see if we have we can extract some information or some patterns that we can share with the management. And after data understanding, of course, we are going to use Python in here and data understanding. Then we are going to move into data preparation, where we will use an extensive Python programming to pre-process the data, to transform the data from a raw data type or from the raw shape into an acceptance format that we can use for an analysis. And after we have the data ready for analysis, now it's time to dive deep into machine learning. So we are going to have a lot of fun building machine learning and cases. So we are going to do machine learning, decision tree, logistical regression, probability support vector machine, and then a project. So we might not cover all of these models. We might simply use machine learning, the decision tree. We don't know what's going to happen towards the end of the program. But that is the plan, and now I'm going to pass the floor to Ed Bojak. I will be monitoring the questions. Just if there is a question that needs attention, definitely we will go through it towards the end of the program, the end of presentation. Ed, go ahead and share your screen, please. So please be quiet and please respect the miking thing. And if you have a question, just put it in the chat. Ed, you are muted.
Yeah, no, I had to reach for it. Folks, you can hear me and see my desktop. It's a Mac desktop.
Yes, we can see it.
Yes.
Yes. Go in the chat and download one file. Well, you'll go to, I'll put it in the chat again in case someone joined in the last few minutes, but it's a tiny URL. It'll go to a Google Drive, and there'll be one file there. So I put it back in the, I put it again in the chat. So here we go. So this is a Mac. So I want to just show you how to do this really quick. Download a file and get it so that you can open it in Jupyter Notebook. Okay. So here we go. Open up your favorite browser.
Ask a quick question.
Okay.
So I try to click on the link, but I'm asked for. I got a page and it says you need access. So I don't have access to that.
Does anyone else confirm that?
Yeah. I was going to say the same thing.
You needed to make it public.
Well, I'll record, okay? Now it's being recorded. So somehow get to the command line prompt. Remember, in Windows, you go to the magnifying glass in the taskbar in the bottom left, click it, type Anaconda, select the one that says Anaconda PowerShell, and you'll get this thing. It'll be white on black or something. Here, the color doesn't matter. You're in the command line. Mac guys, you invoke the spotlight. I do command space bar, and I type terminal. So here you are. So you type Jupyter Notebook, wherever you are, okay, and hit enter. And this will launch a few processes in the background. Now it launches Jupyter Notebook on this. Don't worry, I don't know what I'm talking about. But you're running a web server on your machine, specifically listening to things on 8888. That's the port for Jupyter Notebook. So you'll see that number 8888 a lot, okay? If you're into Jupyter Notebooks. So you say, where did I put it? Well, I don't know. I have a lot of things going on here, so I structure things pretty well. Well, I don't think so. I think so, but this has something to do with 2021 Python for Good, or I'm sorry, Data Science for Good. So here it is. And there's my stuff. You saw that minutes ago, but you don't have all this stuff. You only have that's a directory. So this is the dashboard for Jupyter Notebook. This is your home directory. I'm in a folder called this, whatever I called it, because, yeah, just have some structure. And there it is. There's one and only file, because I put it there. There it is. So there it is on my operating system down in the bottom here. There it is. But in Jupyter Notebook, it gives you, it puts you by default in your home directory. Most integrated development environments for programming and stuff make sense because, I'm eBootjack. I pass this off to some other person. They don't see my stuff because they have to log into someone else. All eBootjack stuff is protected from anybody else. It depends. If you're the only person using a computer, you can do anything you want with it. It doesn't matter. I don't be very conscientious of this stuff. So I don't care about this stuff anymore. So here it is. It's one file. So I have Jupyter Notebook. Here it is. What is and this is maybe okay. So one thing you can do is do a new file within Jupyter Notebook in this directory. So if I click new, it's going to say, what do you want? You might don't worry about all these other ones. You can create a text file here, folder, terminal, another command line, or Python 3. You click Python 3 and create a file. I'm going to do really, really, really fast. So this is you're launching a Python. I'm sorry, you're creating a Jupyter notebook that specifically knows about Python. Okay, so this is Python. So don't type many other languages. Leave it alone. So I'll just say, A equals 5. Okay. B equals A plus 7. And integers, because I don't want to hurt our head. Print B. So most people, if you think, remember, this is an assignment. 5 goes into A. 5 looks like an integer, because Python is the data type is determined dynamically, so that it looks like an int. Lovely. A is a placeholder that points to the 5 number in memory. Lovely. What's this do? Just like math. You're not saying A plus 7. The answer isn't A7. It's whatever the value of A is plus 7. And if it doesn't know what A is, it's going to yell at you. So, but it knows what A is. So it's 5. 5 plus 7. So it looks like an integer plus an integer. 5 plus 7 is 12. B is 12. Well, you didn't ask for it to print out. Now you finally print it out. So it should come out with the number 12. Right? Or you can just say, hey, tell me what B is. Oh, by the way, you typically go up here and hit run. It runs it runs every single line in this rectangular region called the cell. Okay? So it runs this one in sequence. It runs line 1, line 2, line 3. In sequence. Well, this is boring when there's only one line. You run it. It's basically saying, give me the value of B. Okay. Enough Python for now. But you click this run thing, okay? There's shortcut keys. We'll learn them eventually. You can't do everything. So, by the way, another good practice is the moment you open a file, it gives you Untitled, Untitled 1, Untitled 2, Untitled 3. Please, after a while, you'll have Untitled 573. You won't be able to find it. So, depending on what you want to do, I go crazy with the month, day, year thing, because I could always search on something. Something happened the first day of May. I could search every file in May. Oh, look, I got 3 things I did that day. Or, that kind of stuff. And I'd say test. Okay? Test. And it's actually that name .ipynd on my hard disk. Okay? We're developing this thing locally. So there it is. Okay. And these are all IPYND files. They're all Jupyter Notebook files. Jupyter Notebook files always have IPYND files, extensions. And here we go. We're going to finally get into this one. Okay. So remember, we're in the dashboard for Jupyter Notebook. So it's going to read this, read the file, IPYND file, and do the appropriate thing. Jupyter Notebook understands like about 50 languages now. But you have to ask one to be installed because, it just takes a lot of memory. So you only put in the languages you're working with. You don't need all 50 languages. Most people don't work in 50 languages, maybe 2 or 3. So it's launching locally on that file. The other thing you want to learn is okay. Yeah, there it is. Why do you want to use a Jupyter Notebook? Well, one thing it has, what is this? This is nice. This is bigger than this one. It has text. I don't see any code in here. Yeah, these are called markdown cells. So we're only talking about 2 things, is markdown and code. Don't worry about all the other ones. This is markdown. So it's HTML plus more. You can have equations in here that look like math textbooks. You can have pictures. You can have images. You could be producing graphs, charts, whatever you want to call it, and it will send the output to a cell in this notebook. Everything will be in your notebook. Everything. Well, it doesn't have to be, but it's nice. So it's great for teaching and learning. You want to use Jupyter Notebooks for anything that sounds like a notebook that to deal with teaching and learning. It really helps. And you're data science guys, folks. So Jupyter Notebook is great for exploring stuff, experimenting with stuff. So it's great because that's what we do a lot of the time. Data science, machine learning people, or even scientists, they experiment a lot. I mean, with code and seeing charts and predicting things that they think they saw, that kind of stuff. So Jupyter Notebook files is pervasive. So if you get anything, Jupyter Notebook files are everywhere. It doesn't have to be Python, okay?
Ed,
So-
quick question, please. Why are you naming Python as crash?
No, this is a crash course, meaning you learning it really fast. Crash means you do it fast. We're going to learn it fast.
Okay.
And you definitely, remember, don't think you know everything. I'm constantly learning things. So subscribe to everything you possibly can. Blogs, YouTube videos, channels, playlists, whatever. And you might learn something new, but you probably will. Oh, here we go. So this is just a markdown, with the 5 machine learning libraries. We don't know what they are. So there's Pandas, and then there's, don't worry, I'm just scanning for the titles. Numpy, and I'm just looking for the numbers, okay? We lost 3. 1, 2, 3. Scikit-learn. We'll talk about it. Matplotlib. We'll talk about what that is. And NLTK. So here we go. Pandas. It's great for data manipulation, data munging, exploratory data analysis, anything that sounds like it. So anytime you import a library, leave it alone for now. Python doesn't call them libraries. They're called packages or modules. But if you ever dealt with any other programming language and you said libraries, yeah, you imported them, you included them, whatever word your language uses, and you get all that functionality by bringing in that library. Pandas is one of them. So is Numpy. And we'll deal with them one at a time. Pandas is for data manipulation for data. It has 3 data structures. One is rows and columns, like you would think in a database, like a table. Okay, think Excel spreadsheet. One sheet, just only one sheet. It has rows and columns. Rows are typically numbers, 1, 2, 3, 4, 5, and the columns are typically A, B, C, D. Well, there's kind of stupid names. Can we have better indexes and better column names? Yeah, you can. Pandas does it for you. So it supports the 2-dimensional data frame, called data frame. It supports the 1-dimensional thing called a series. That's typically a column. And it also has indexes. So you don't have to say, column 5. So you'll be scratching your head and I'll be scratching my head. What's column 5? Oh, why don't you just say column that's called age? Oh, it's the age column. Good. I know what you're talking about. So please use the structures that are inherent in any computer language to help you. Column 5 is meaningless. Because if you delete a column or shifted 5 is not 5 anymore. It was moved over to 4 or went up to 7, whatever. So stop talk to things with names. So how do you get Pandas functionality? Well, you import the Python word is import. You import anything that looks like a package or a model. It's called Pandas. But people don't feel like using the word Pandas because it's just too many letters, and it's 2 syllables on top of that. So they typically give it an alias called PD. Please just use PD. Everyone, if anybody sees PD, it's like, oh, there's a 99.9% chance that it's probably Pandas. Okay, so as is an alias. See, but whatever that is, that's your alias. So you just say PD dot. A lot simpler, okay? Okay. Oh, by the way, this is 1. It's the first cell I ran. So I'm going to run it again. I'm going to explicitly hit the run. I don't like reaching for the run. It takes too much work. So it's the second time it ran something. Well, I'm going to run it again. 3rd time. So this number goes up. 1, 2, 3, 4. So keep track of that. You don't have to memorize it. It's the 3rd time I ran it, okay? Not that cell. It's the 3rd time I ran any cell, okay? So if we run this, it should be 4. Oh, I'm going to run it this way, 4. So this is a different way to import. Most people don't do this. It is the better way to do it, although most people don't. It's very memory efficient and a few other things. So the things I said is anytime you import things, you get a lot of functionality and most of the time you get some kind of data structures. The 3 Pandas data structures you get are the big one everyone knows about is data frames, 2-dimensional, rows and columns. Good enough. If you look at one column, they all have to have the same data. It's a series. And just think of an Excel spreadsheet, or not Excel, but the generic word called Excel. A spreadsheet. If you have a column, everything in that column has to be the same data type. Are they all ints? Are they all floats? Are they strings? Are they whatever else? Date, time, things, anything. But they have to put the same date type, okay? The other data structure you have is the index. so you can actually put names on the rows and the names on the columns. You know, just like in Excel. You know, you don't have to have columns named A, B, C, D. You can rename that. Okay. So here's a series, one-dimensional. So there's a list of integers, and this is Python because you're new. It's called a list. Don't say array. These don't have to be the same data type, but what's also important, a list, you can have repetition. Okay. Can you have multiple entries? There's 5 entries in here. Can they have multiple entries that are duplicate? Sure. They don't have to be unique. So here's a list of what appears to be 5 integers. Okay. I want to make a series, a Pandas series. So you say, what's going on? 3, 5, 5, 9, 6. What is this? 0, 1, 2, 3, 4. That's the index. Okay. So I could look at, I want the second, better not pick that. I want the third element. Can I do this? We'll leave it alone. Leave it alone for now. Okay, head. That shows you the first 5 rows. Well, that's kind of silly. There is 5, so you can't tell. But you can say, show me the first 3. Show me the first 20. Show me the first whatever. So you see, well, it's kind of boring. It is. Wait till we get to data frames. Okay. Head, and there's the opposite head is called tail. And it did come from Unix, the head tail utilities. Okay, Mo said you'll be doing this tomorrow, but just for fun, what else does Pandas do for you? Well, it does data manipulation of all kinds. It also does some cool statistics. Like when you'll be exploring your data, first thing you'll say is, show me the mean of this column. Show me the max of the age column. What do you mean the maximum age is 573? I better investigate that. Assuming it's humans, this is not right. You know, we got to do something with that number or anything that sounds like it's above like 150. You know, human age, okay, or negative ages. What do you mean negative ages? What do you mean an age of dog? No, ages should be numbers. You know, integers or floats, one or the other, that kind of stuff. But what else can Pandas do? Well, you can read and write to humongous amounts of different type of data formats, tons of them. Well, and you read your data with read, and you write your data with TO. So if I want to do some stuff, change some things, delete some columns, delete some rows, change some numbers, and then write it out, I say pd.to, and you just find the one that you want to write. Is it PDF? Is it Excel? This is CSV. So CSVs are common across multiple operating systems. A lot of people like CSVs. You know, if your data is not humongously big, then you have other ways to deal with it. You don't do CSVs. So I don't know if you paid attention when you deal with your spreadsheet thing. When you do a save, you can export it as a CSV file. Why? Because I export it. I mean, I save it as an Excel spreadsheet and mail to you, email to you, and the chance you have an Excel is pretty slim. But if I save it as some standard boring format that's independent of tools, operating systems, all that stuff, CSV is it. Well, it's comma separated values, okay? And you're going to this place. So this is kind of cool, so it'll make life easier for tomorrow. Well, I can read from a file, but I also can read from a URL. That's a URL. So let's just try this. I copy and paste it up there, guys. I don't know if I blinked. And it was a tiny URL, so it expanded to this. Oh, there it is. Here it is. So notice the top row, it has column names, but you'll see this is about UFOs, just a big picture. Oh, okay, it's still catching up. But city, colors, no color, triangle was the shape. Reported was 6/1/1930. No state, no time. But you can see it's separated. The values are separated by commas. Okay, that's what CSV stands for. Here we go. So I'm going to read from this URL. Okay, and this is optional because it's this here, but you'll learn about that tomorrow. Okay, and we'll read it. Yeah.
I tried to run the list s equal pd.series, the list of numbers, and I get like attribute error.
Capital S. Did you type this in, or did you get it from here? So
No.
capital S. Python naming convention follows when it names objects. When Python names objects, it follows a normal convention that most object-oriented languages do.
Oh, okay. It works now with capital
They
S.
do what's called camel case. Every single word is uppercase, and then it goes down, then it goes up. I know there's only one word, so you only see one capital letter, but you'll see right. Okay, so here we go. Read it. Okay, so a star means it's running. So sometimes you'll have that asterisk or star here, meaning your thing is taking a good long time, like it might be going out and doing some wonderful things, or you're humongous amounts of computation in this cell somewhere. So it's saying it's star. And if it gets hung up, you can interrupt it. Just like you can. Okay, so UFO. What is a UFO? So I'm going to just do this. Data type. Tell me the type of what's a UFO. It's helping me too much. So it says it's a Pandas, blah, 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 data frame. So you see the D is capital or uppercase and the F is capital or uppercase. So this is, because of the way it's named, I can tell, 99.9% of chance it's probably an object. And everyone behaves when you code. Don't make everything uppercase because you feel like it. Don't make everything lowercase because you feel like it. Follow some recommendations or standards for whatever language you're in. Okay? So this is almost surely an object, and it is. Okay? Because besides the fact that I told you to. Anyway, so yeah, what Pandas, if everything was successful, then it gives you back a data frame. You're saying, hey, Pandas, do a read CSV. Got it. So you got it. There it is. But what do you want to do with it? I don't know. Show me the top 10. Records, rows, observations. All these words mean the same. Okay? So there it is. Okay? And it's only the top 10 because I only asked for the top 10. And it's 0 based also. So 0 to 10. 0 to 9. And there it is. And blanks are indicated with Pandas with NaN. NaN stands for not a number. And you say, what's not a number? It's everything that's not a number. Is a string not a number? Yeah. Is infinity not a number? Yes. Yes, Python has infinity. Very useful. It also has NONE. I have a variable. It's not initialized yet, so it's called none. Is none not a number? And not a number is just integers and floats and these other numbers. So and can it be blanks? Yeah. So this Pandas, when you see NaN, it's a blank. So record number 0. The city is a UFO. Something was reported in Ithaca. Where? New York. It's a few Ithacas, so you got to get city and state. Okay. What was the color? No one reported anything. Want to repeat what? It's a triangle shape, and it was reported July 1st, 1930. At 10 o'clock. At 10 o'clock local time. Yeah. There you go. Lovely. So NaN is blank. Okay. So can you look at one particular column? Yeah, I want to look at the states right here. The state column. They all should be the same data type. What do they look like? I don't know. They all look like strings. And they all look like 2 letters, but it doesn't have to be. So let's look at the states. So what you said is, you said UFO, this object-oriented program. You said UFO dot this, UFO dot that. Well, what else can you do? You could say, hey, let me look at the state column. This is what Pandas allows you to do. You don't have to say state. Third column. Remember, 0, 1, 2, 3. If I say UFO 3, bracket 3, you're going to say, what the heck is the third? Oh, it's a state column. You should not say that. Just say state. I don't have to think about it. Look at the UFO data frame and show me the state column. And there's a lot of them. Oh, let me run it first. So I'm here. Oh, by the way, you don't have to put the cursor at the end. You don't have to put the cursor at the beginning. You don't have to put the cursor in the middle. You don't have to highlight it. Just put the cursor anywhere. Anywhere, any line, anywhere. When you say run, it runs the entire cell from top to bottom. The rectangular region is the cell, okay? And if it has output, it will create an output cell. So in 11, produce out 11, unless you do fancy stuff. Now, what's kind of cool around here? What if this were 500,000 outputs? You're going to have 500,000 rows. You're going to be sitting on twiddling your thumb while scrolling across the screen. You probably did not mean that. So it will do this ellipsis thing. Well, it's not an ellipsis, but the 2 dots are 3 dots, both horizontally and vertically. So it says, well, I don't think you meant to list all of them. There's 18,000 of them. Well, 18,241 of them. I don't think you meant that. So it'll throw an ellipsis in. It'll show you the first few and the last few. And it's like, yeah, I meant, yeah, that's right. Now, you can also, what else can you do with data frames? Remember, it's meant for data manipulation, so it's going to do a lot of stuff for you. So I'm going to ask for a describe of it. A describe method on that UFO object. What is a UFO? Well, it is an object, but it's specifically a Pandas object. Specifically, a Pandas data frame object. So Pandas things know how to do a describe. So it's going to do the, it's going to do some statistics on it. Okay. Now, the weird thing about this data set, there's no continuous data. What do you mean, continuous data? Well, city is a string. It's not continuous data, as opposed to discrete. Discrete, it means it's only so many of them. So you'll hear the word categorical. Well, what's categorical? Well, state is definitely categorical. There's only so many states, right? Now, the question is how many states are in this data set? You know, you say there's 50. Well, this might, and you'll count the states of it, it'll be 38. Because some states maybe didn't have UFO sightings. So don't get shocked. It's like, I expect state to be 50. No, well, 50 unique ones. So, you know, is shapes continuous? No. There's only so many amount of shapes. You know what I mean? You know, that kind of stuff. And so all of these are categorical. So when you do a describe, it does this unique ones. So how many unique cities are there? Wait, I thought you said there were 18,400, well, 18,241. But that's the states. So how many states do you have? 18,241. That's what we just said up there. Well, how many cities do you have? Wait, you don't have 18,241 cities. There's approximately 30 cities that are missing. It just has a state. Okay, sounds good. You're a data scientist. You better figure that out. If city is important to you, there's 30 cities, I don't know, roughly, I don't know if I'm doing that, or 20 maybe, that don't have cities. Should I throw them out? Maybe. So, how many unique cities are there? Well, 646,000. Lovely. Right. Okay, and it's 52 states. So, you know, it could be because you typed in a state called TI. There's no state called with the acronym TI. Okay, so you got to check these out. Why is there 52? There is no 52 states. Okay, so did somebody misspell something, or maybe Puerto Rico's in there and Guam and all the other things, but maybe. So you got to look at that. If you're a data scientist, you better check that stuff out. Okay, and this is kind of cool. Remember, so can you look at the shape? Yeah, it's only two-dimensional, so it's 18,241. You should not be shocked. But there's also, that's the number of rows, 18,241, and the number of columns is 5. Right. The data types. Well, I'm just going to run it. And the data types are of the columns. So the city column, yeah, it's an object. So object is anything that it cannot, Pandas cannot routinely identify. And people, object does not mean string. Because look, time. Time is, you know, a date time thing. Well, it's not the way it likes to see date time, so it says it's an object. So object is a catch-all for Pandas. You know, if there were ints, if it had age in here and they were all integers, it would give that age column. It would say the data type of the age column is int, or float, or something else. Okay. So unfortunately, these are all the same things because none of them look like Pandas could successfully identify the data type. So it throws it into this thing called an object. Lovely, and you can convert them later. Okay. So I'll say convert state to a string, because that's what it is. It's 2-letter string. But yeah, right. Columns. Columns is give me the index that, by the way, there's actually 2 indexes. There's indexes on rows and indexes on columns. But, you know, most people don't know that. But the columns is an index also. You can talk to that column with that name. That, you know, it's a URL. You can put in any.
I ran the same exact one, UFO equal PD.read_CSV. I didn't put the rest, and I put under that UFO that head, and I get attribute error.
Well, they have to be in quotes because it's a string, right?
Oh, I have to include that URL as well.
You can say read CSV, it's going to say, what are you talking about? Where you got to tell me where to read it from. You got to give me a file name in quotes, of course, because it's a string. You got to give me a name of a file or a URL or a few other things.
Okay,
Most
that makes sense.
files or URLs. Well, what does that mean? Well, I don't feel like putting this stuff on my hard disk. It takes up space. And by the way, I could take this file anywhere. I don't have to sit there and give you data files. I'm gonna go out to the web. Oh, assuming you're connected to the internet, right? This will work, right? Okay, so there it is. I read it. Then I said, hey, you see this colors reduced, colors reported column, these NA thingies? Okay. I don't think that column's important. And we'll just look at a few other things like wait. Oh, it's not square. What is this? It's supposed to be square brackets. I knew this is right. So remember, if there was a bracket, there's a right-hand bracket.
Muted.
241 of them, but there they are. Okay, there's the colors. Okay, and also, you know, the ones which are blank. So how many are there? I don't know. I could do the length of them, but you know. Oh, they didn't tell you this. So here it is. What you're saying is I don't like that column anymore. The color is reported. It has no effect on what I'm trying to produce or trying to predict because you know we're data science people. So I'm going to drop that. I'm going to drop, and it's called drop. You're going to. Oh, and by the way, and
Muted.
itself in place. So this will actually modify it. So UFO head, well, not UFO, the entire data frame, this colors reported is now no longer there. Okay. So if you look at UFO shape, it will be one less column. So it'll be 182414. Right. Okay. So I'm going to drop state and time. Wait, I can drop more than one at a time? Sure. If you got more than one at a time, you got to give me a list of them. So this behavior is true a lot in Python. You know, if you only have one, you could just give it to me as a string or whatever. But if you have more than one, you give it as a list. And there can be one element in there, 2, 750. It doesn't matter. So I'm deleting state and time in here. So state and time, I'm going to have hardly any columns left. Yeah, there it is. So that's dropping state and time. But if it's only a column, okay, so we're deleting columns. So we're going to reread the data because, you know, we're just having fun up there. So you're going to reread the data, and there it is. Yes, same as before. You should not be shocked. I want to sort these things. Okay? I want to say, hey, you UFO data frame. That's Pandas. Remember, this is all about data munging, sorting, searching, rearranging, doing math, dropping, filling numbers in that shapes anything. So here it is. I'm saying, hey, UFO, look at the state column. There it is right there in the exact spelling, state column. I want to sort the values ascending. And okay, oh, ascending is false. So it's going to do descending, right? You're going to have the Z's at the top, assuming these are all letters too. Okay, and you only want to look at this. So let's break this apart because you're first learning. So we're going to say UFO.state, and here they are. And just like here, well, we only have the first 5 there. You know, New Jersey, Kansas, Colorado, New York. Right? Yeah, got it. New York's there twice, but who cares? Now, there's another way you can do this really quick. And so you'll mix and match these, and you'll see these in codes everywhere. You can do this. UFO state is capitalized, right? So these last 2 cells, they're the same. So some people will do dot that. You'll see this a lot in languages like R and other things. But Python says you can have that way or this way. I would say that's more prevalent in Python because how do you say colors space reported? You can't use this way. You can't have spaces in the middle of a code. So you have to do it this way. Okay, so that's the UFO state part. That's the beginning part, okay? And then you said, I'll do it this way. So anytime you see code, just break it into little pieces. So it's sort, right? Oh, sort values. Oh, I'm lazy. Sort values ascending false. So that'll be descending. Okay, I'm gonna run it. Oh, there's 18,000 of them, folks. So sorting is not like infinitely fast. Oh, there's no state with this city, right? Wyoming, right? And what happens is it sorts them, and you would think that's Arkansas is probably the first one, yeah. AK, right? Right. Alaska is right behind them, or Alabama too. So notice Wyoming occurred at the 12,079th one. Another Wyoming occurred at this. So the index travels with the data. Very cool. Now you're saying, I don't think, oh, I didn't mean to do all that. So what you want to do is you take this. So this is called chaining. When you do this, well, there's only one. When you do this dot, 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 dot thing, it's called chaining. So you can don't go like 20 of them in a row. People won't like you. So, but if you're doing something like this, it's not that bad. There's only 2 dots, and dot is an operator. It's what a lot of people use in the object-oriented world. So I'm going to say take whatever is there on the left-hand part of that dot, and you know I only want to look at the top 25, or I'll do top 20 because I want to be different. Or 10. Well, 10, yeah, we'll hit something other than Wyoming's, unless there's 10 Wyoming's. Oh, it's UFOs. It might be 10 UFOs, 10 Wyomings. Oh, I gotta run it. Oh, there is. Yeah, remember this is UFOs, so okay, I'll just go for 20. You know, you're going to get a lot of UFOs in not urban areas or not heavily populated states. That's a better way to say it, I guess. Oh, come on. Oh, it's helping me too much. 20. Good, we finally get some. I can't take it anymore. So we're just going to do the 25 one, and hopefully there's another not Wyoming showing up. Oh, Wyoming is very popular for UFOs, apparently. Okay, so let's do a tail. Oh, you can do a tail. Oh, we haven't done a tail yet, right? So we'll just do a tail. Remember, it's reverse sorted, so these are going to be the states that begin with A. And I'll just do 10. Oh, okay. Oh, AK. Okay, did we say Arkansas? Anyway, no, AK is Alaska. Yeah, not populated, not heavily populated. So UFOs are going to hang out there. Okay, just show the head. If you don't do, only on the head. So I'm going to sort the values by city. Wait, so it's going to be ascending. So you're going to have the cities that begin with A at the top, and show me the top 5. Oh, Abbeville, South Carolina. Okay, Aberdeen, Washington. Wait, Aberdeen, no. So this is what you got to do as a data scientist. Just looking at the city is not good enough because there's a few Philadelphias. And there apparently, because of this, there's a few Aberdeens. This Aberdeen is not the same as this Aberdeen. look, you got to make another column that looks like city state. So this is Aberdeen, Washington. This is Aberdeen, Ohio. This is Aberdeen, Washington again. And this is Aberdeen, South Dakota. Apparently, there might be more Aberdeens, but just looking at one column is not good enough. You'll learn that in data science. Please be careful. Right. So we're going to sort city, then state. So you're going to say sort the cities first. If there is an overlap, go to a secondary sort by the state. So, and we're going to do the head. So you'll see Aberdeen. There'll be at least 3 different Aberdeens: Washington State, Ohio State, and South Dakota State. And they're separated. Notice that, there's a Maryland. Yeah, Aberdeen, Maryland is the big one. That's the military testing grounds. So Aberdeen, Maryland. So it's Aberdeen, Maryland, because Aberdeen. See all these Aberdeens? So Aberdeen, Maryland, there's 2 of them. M occurs before O, occurs before S, occurs before W. Oh, there's Aberdeen, Washington. This is a very popular UFO place. Okay, sounds good. Okay. So remember, you can sort, and by the way, this does it for all for you. So when you sort, remember Pandas, so it does sorting. And this is sorting by, you're saying, look at the city column. If there's overlap, do the state column. Well, Maryland. Well, what if you want to sort, can you say city, state, shape reported? Sure. Can I do city, state, time? So sort it in time order. And the time, it's very low chance of that overlapping. Okay, so I might want to do that. Washington. Yeah, there's no order to this Washington stuff. Well, actually there is, but it might be pure luck. Okay, and by the way, it's not just focusing on Aberdeen. It did Abilene too. There's Abilene, Kansas twice, and then becomes Abilene, Texas 3 times. Okay, so it's sorting. Primary sort key, secondary sort key, if that means something, if you know how to sort. Okay, go away, please. You're reminding me too much. Oh, you don't see that, dude. Okay, here we go. Okay, so this is your intro to Pandas. So Pandas is for data manipulation. So it does, and we only dealt heavily with, except for that intro one, with the series. So if you look at, this is a data frame. Each column is a series. So if you look at the city column, all of them look like strings. Yeah. If you look at time, they all kind of look like date time things. Okay. Sounds good. So, right. Any question on, by the way, Pandas, there's a lot of crossover in a lot of these, these packages. So does Pandas do statistics? Yes. Well, can I do the statistics of the city column? It's a string, dude. You're going to do math on strings? Yeah, that makes no sense at all. So if we had some numbers in here, we could do statistics. We could say, hey, look at the look at the age column and do a mean. Do the standard deviation of that column. Do the whatever. I'll leave it alone for now. So you can do statistics. What I'm saying is Pandas can do statistics. It can also do some data visualization. Its specialty is what we've seen right here. It's pretty good at graphing. It's not phenomenally good. It's pretty good to get you a good idea of your data. Is it normally distributed? I don't know. Look at the city. Oh, there is no. If this looked like the continuous data, I would say, hey, look at the plot the time thing and does it look normal? Or does it look flat? Is the or I can strip the time and I could say, hey, do most UFOs show up? What hour do most UFOs show up, or reported? I should say they don't show up, but and you can say, oh, most of the time at nighttime. Okay, sounds good. Okay, that's what data science people would do. Okay, and by the way, plot it over a map of the U.S. Where's their high concentration of UFOs reported? Well, based on that data. Okay, and you'll say, oh, they don't like heavily populated areas. No, you have data to back it up. It's not your belief or your notion or just listening to people talk. It's like, no, this data says it doesn't like populated areas. It's going to states with low population, and more specifically, it's going to, not near cities. But and where do you get that data? You need more tables. I need more tables that tell me other things, like, big cities and things like that. So this is NumPy. So NumPy, you say it's num, but by the way, many packages that deal with Python will have py somewhere in its name, py in the front or py in the back or somewhere in between. So this is NumPy. So you would think it does number crunching, but it's not. It does more. It's claim to fame, and this is the core package you want to know. Everything is built on top of NumPy. It has a dependency on NumPy. So what does NumPy do? Well, it does n-dimensional arrays. What's n? N is any positive integer. So it does zero-dimensional array. That's what's called a scalar. It's a number, or it can be a string. So it does n-dimensional arrays insanely fast, insanely well, and lots of other things. And that's what made Python take off, is this package. Python was just a general purpose language, but NumPy came along and everyone said, this is great, it's really fast. Well, it's not as fast as compiled languages because Python is interpreted, but with NumPy, it made it easy and fast. And you didn't have to write all the code. It was written by the people who wrote NumPy. So its forte is to handle n-dimensional arrays. 0 dimensions, 1 dimension. One dimension is a row or a column, and that's what some people call as a vector. What about 2-dimensional? Well, most people call that like a matrix or an array. But what about 3 dimensions? What about 4 and 5 and 6 and 7 and 8? Sure, no problem. It deals with it all. And if you have to write that code for it, you'll be writing tons of loops, and you're probably going to mess up somewhere. And then somebody inheriting your code has to sit there and try to figure out what you did. Well, if you just use NumPy, everyone knows it. This is what they do. Okay? Well, so it supports an n-dimensional array, and we'll see it. And you can read all this stuff later. Remember, it's not just about numbers. It's an n-dimensional array, n meaning in positive integer. So if you have a 2-dimensional array, that's rows and columns. And other data types. Every single element can be any data type. So here we go.
Muted.
Array. When you hear the word array, if you're new to programming, array means everything has to be the same data type. Every single element in that collection has to be the same data type. The moment you say that, you lose generality, because a list can be anything. A list can be 1, Python, 17.3, Fred, a list of things. Wait, I had like 3 or 4 data types there. Yeah, you can. But an array, when the moment you say array, you mean they're all the same data type. So if you just looked at this, just the inside part, you say, oh, it's a list of what appears to be integers. It's a list. That's what square brackets do. But you're saying, I want to convert it to a NumPy array. So you say, hey, NumPy, take whatever is in these parentheses and attempt to make it an array, meaning a NumPy array. Okay? So what you do is you first import the library, just as before. In NumPy, people don't like 2 syllables and they don't like 5 letters, so they import 5. So they make it NP. So please don't name your variables NP, because everybody who sees NP, it's like, oh, it's a NumPy thing. And if it isn't, you'll mess up their head, or you'll read the code a year from now. It's like, oh, NP, it's a NumPy array, and it's not. So don't call your variables NP. There's certain words you don't want to touch, because it's just a convention. Don't name your things NP unless it's NumPy. Okay, so here's a NumPy array, and how do you know? The formatting is one thing, but also put array in the front of it. If you ever do the data type, it'll say ND array. It's an n-dimensional array. Okay, and you'll say, well, what's the dimensions? We can argue all day. Is it vertical or horizontal? Don't worry about that one yet. They are different. So let's look at the shape. It'll say 5, whatever. And I don't feel like explaining why it does this. It has something to do with, leave it alone. If you see this, what it says is, it's 5 by 1. What's the length? Well, better say 5. By the way, this length, there's a bunch of built-in functions like len, len, sum, max, min, that kind of stuff. And it will work on almost every data type. So you say the length of this thing, the length of that thing, you say, yeah, there's 5 elements in that thing. Okay, they got a 5. Well, you can't do the length of everything. You can't do the sum of everything. You can't do the max of everything. You can't do, oh, here it is. You can't do the length of an integer. Wait, an integer. It's only one number. You're saying, give me the length of 7. Wait, it'll yell. So you can't do that. You're asking for silliness. So just because you can't do the sum of 7. It's like you're summing an integer. Well, what if I said the sum of the list of 7 and 3? Oh, it'll say, yeah, I can do that. 7 and 3 is 10. So you can look at the size, and there's size is number of elements in there. There's 5. Now you say, well, how come size and length are the same? This is one-dimensional. What if it were two-dimensional? If say it was 5 by this, if it was a two-dimensional array, 5 rows, 7 columns, this size will be 35. Yeah, 7 by 5. There's 7 rows, 5 columns, if I said it right. It's just, there's 35 elements in that array. Okay, can you look at the data type? Yeah, now notice this says D type. This is looking inside. Wait. We said look at the type of X. It says it's an n-dimensional array. Yeah. That's looking at the outside shell, if you want to call it that. It looks like a Numpy n-dimensional array. And yeah, that's true. But what's inside that thing? You said you do X dot D type. And you'll see this D type showing up a lot. And if you see this D type, I don't know if you remember it. You saw D type in Pandas. The D type. Int, I hope. Right. Oh, it's an int 64. So this is 8 bytes. Wait. I'm only storing numbers that
Muted.
2, 3, 4, 5. 8 bytes for that integer. 8 bytes for this. And we're not here to talk about memory efficiency and all that for speed. You want to make the thing as little as possible for memory footprint and also for speed computations. So, is every one of them is 8 bits, 8 bytes. It's 64 bits. Every one of those elements is 64 bits, meaning 8 bytes. That is overkill. I only want numbers between 1 and 5. I can represent that in 1 byte. 8 bits. Yeah, dramatic increase. You say, but there's only 5 elements. Yeah, that's true too. But we're data scientists. We don't get a data set of 5. We get a lot of data. So you might, if you keep doing this stuff and wasting memory, you might not have memory on your machine. And your answer is not just buying more memory. Why don't you just reduce the size of the memory of the stuff when you import it? Because you don't need 8 bytes. Okay, enough of that. So here's X. It's going to just display it. It's one-dimensional. So here's the thing. How do you get into or index into these things? So it's 1, 2, 3, 4, 5. So you say, give me the 0th element. So Python, just like Python, NumPy array follows the same thing. It starts at 0. So it's 0, then 1, then 2, then 3, then 4. So you say, give me the 0th element. Now, can you also have done this? It's only one-dimensional. It's the same. We'll talk about that when you get into 2 dimensions, but we'll get there. So here's the 4th element. 0, 1, 2, 3, 4. It'll be a 5. You hope. We hope. Yeah, good. Now, what if I say, give me the 25th element? It'll say you're just like Python will say, we don't have one. We don't have that. So X 25 or anything bigger than 4, actually. Remember, its length is 4, but you index it with 0, 1, 2, 3, 4. Wait, did I say that right? The length is 5. There's 5 elements up here. And I say elements, and a lot of people say elements because, well, it looks like integers. It could be anything, but they all have to be the same. So everyone just calls them elements. If you have a collection of things, people call them elements. Okay, each one is an element. So X25 will say, you're out of bounds, and index are you can't right? It only has, right, 5. You can't give me a number bigger than 4, actually. So this says, just like if you do a loop, what this says is, so it goes like this. So you give it like a Numpy array, and you say start, stop, and step, just like you do in a loop. Start, stop. So that's I'm gonna make it a comment, a one-line comment. So there it is, and you'll say, well, what if I don't give it a start? There's a default, and this is how you indicate it. You say the default is 0 in Python. You say default is 0. If you don't tell me a start, you're getting 0. If you don't tell me a step, you're getting 1. So it's going every 1, and there it is. So you say start. You didn't give me a start. Well, I'm going to start at 0. Well, did you give me a stop? Yeah, it's going to go 0 to 3. 0, 1, 2, not including 3, just like a for loop. And these all have to be integers. You can't have integers. You can't have indexes. These are called indexes. Okay. You can't have fractional indexes, just like you can't have fractional people. You can't have fractional paint cans, anything. You can't. Right. So, so one more just to below. So you're saying, and this you can do this in normal Python too. But what I'm saying is, in Numpy it does Numpy does whatever Python does plus more. Okay, but only with arrays. Okay, so here we go. And I said X. And what do you want to put here? Well, what if I don't give it anything? It shows me everything. Okay? And we'll do one more. X. I'm going to start X. I'm going to start at the first element. So it's going to start with the number 2. Okay. Really bad at typing X, apparently. I'm going to start at the first element. What's the first element? Well, it's 1, 2, 3, 4. The first element is a 2. 0, 1. So it's going to start the first element. It's going to go to the end. And if I didn't say anything, it'll print out 2, 3, 4, 5. Lovely. But I'm going to jump every 2. So it started at the first position. It jumped 2. And then it tried to jump 2. It says, no, I'm out of here. I exceeded the bound. So you're only getting those things. So you can play with this forever. This is called slicing. You can slice in multiple dimensions. Multiple dimensions. Yeah, that's when you need the comma. Meaning 2 dimensions. So can you save things? Yes, you can. So there will be a file called X. Okay? So how do I do this? Well, I'm just going to show you something really quick. Okay. Okay, here we go. Add a cell. You can jump to the operating system anytime you want. You can do a dir if you're on Windows. If you're on a Mac, you'll type ls. ls, actually. Okay. Just ls, okay? and there it is. Now, remember, this directory is pretty pathetically short. There's only 1 file. Well, actually 2, because we created that test one, right? So now, you could do that, or if you're smart, use Jupyter Notebook to help you with this. So what you'll do, you'll say, hey, Jupyter Notebook, I don't care about what operating system I'm on. I'm going to be giving out this IPYMB file to everybody, and they're going to run on like 700 different operating systems. Well, talk to Jupyter Notebook to do the directory for you. So that's a %sign, folks. I made it bigger, just a little bigger. So okay, it's a %sign. So and by the way, the commands that most people do is when they jump to try to generalize, they will jump to Unix. So it's ls. So this will work on any machine, folks. Oh, that knows how to use Jupyter Notebooks in the browser. Okay, so there it is. And if you really are cool, you'll say, give me some information. Give me a longer directory listing. So it's a lengthy. It's a long listing. That's the L, and the T says, give me the times also. So there it is. So there's some Unix permissions. Who cares? That's the size of the file, and it was 1321. That's the last time I did a save, or it did a save. So it automatically, up here, it automatically saves, and I could force a save. So it's auto-saved, and this if I refresh, it'll be 1322, or is it 23? I don't know. Yeah, it updated. Okay? So this is a long list, and this will work on any operating system. because you're talking to Jupyter Notebook right there with the percent sign. Okay, so you see no X file here. There's no X. Well, I'm going to run this. What you're saving the X data. This NumPy thing is X. So anytime you get data, there's always a way to save it. Okay, and a lot of the packages will let you save according to its native format that it likes. But there are also some generic ones out there. So we're in NumPy, so let's focus on NumPy. So, you say XX, and if you're into programming, this will make a lot more sense. You'll see some code that says X equal new X, X, X. And it's like, and all those X's are not the same. So I'm going to change this just to show you. I'll just call X file. Yeah, almost like that show. But the X file. So in my directory, after I run this, it's going to save this. Remember, we're NumPy. So this hopefully is a NumPy thing, an n-dimensional array. It's going to save that data into this file called X file. Now notice there is no file called X file. There's only 2 files out here in this little directory. And I could also do things like, at the end of it say, show me only the ones that start with X. But I'm not here to teach you all that now. So you're going to try to save this X NumPy array into like right here. Now you can give it a whole directory listing and other things on top of that, but I'm just going to call it X file. Okay, and I'm going to run it. I'm going to run the cell. Okay, there's only one line, and I'm going to, because I'm lazy, I'll copy this again, and you'll see that the file does exist. Now, I could jump out to the operating system and you can see it, or I can open up another window over here, and if I say to save, it'll be created. But, this is me just teaching you something about Jupyter Notebook. X, see this X file? It got created, it's 34 now, 35. But it's a real short file. It's only 168 bytes, and it got created, a minute ago. Cool. Sounds good. Now, you might want to do this at the end of the day, or you want to mail this thing to a person, and it's like, what's an NPY file? See, it's an NPY. What's an NPY file? I click on it, and I click on it, and it's like, this is gibberish, and then you say, oh yeah, I forgot. So you might want to save it out as a CSV. Okay, that'll work, and then you can read it. But if you save it as an NP NumPy native data structure out to the disk, and it's called persisting. A lot of people call it persisting your data. Well, how do I make my data persist? Write it out to a file. Pretty much is the answer. Well, how many ways can you write it out to a file? Find out how many ways there are. There are a lot of them. If you're using NumPy, you can use this, or you can save it out as a pickle file, or anything. Yeah, they have weird names. So you'll see a PKL file. It's like, oh, it's a pickle file. Now I got to read it as a pickle file. Yeah. Well, if you know it's an NP file, NPY file, you should read it as an NP. Use NumPy to read it. So isn't it? Oh, by the way, it's called save, and the opposite for reading is not read. It's load. So if there's a load method in NumPy that does it. So I'm going to assign it to a variable. I'm going to call it X. I'll call it Y. Well, you're loading it, and if you don't say otherwise, it'll echo it to the screen. But I'm going to assign it to a variable Y, and it's like, oh, it's not X. I went through the trouble of naming it X file. So here's an interesting thing you should know. This is called the traceback. This is how Python yells at you, and you can actually create these things and process these things. You can say, I know if I get an error, I'm willing to accept file not found error. I'm willing to accept division by 0. I'm willing to accept the data type is wrong, and other things. So there's a bunch of these errors, this is called exception handling, not today, but, there are things you're willing to accept, ACCEPT, and stuff you're not willing to accept. And it's about this. Now, if file missing, that's what this is, file not found. Well, the file not found, and by the way, it might be found, but you don't have read permissions. Somebody, it's there, but you can't see it. No, we ain't letting you see it, is a better way to say it. You have permission problems. So this one is just the file. Yeah, you asked for file X, and it said, there ain't no file X here. Yeah, because I renamed it. Because I didn't want you to look at XX. It's like, what X? Does that X have to be the X? No. You can name it any file you want. Okay? So I'm going to do this one again. No error. But it's like, wait, it didn't do anything. That's what I wanted. It didn't do anything. No, it did a lot. It read the file. It didn't have any problem with reading it, and it assigned it to the variable Y. And you look at the type of Y, it better be NumPy NP array. Yeah, it is. And finally, let's look at it. And I could just print it out, just say Y, or print Y. And there it is. And you're not surprised. I can hear you. Okay? The big thing on NumPy, it allows you to do a lot of statistics well, and in any dimension. Well, we only dealt with one dimension. That's true. So give you a demo of that. So you say Y, mean the variable Y. Y dot mean. Do the mean of that. By the way, stop saying average. If you're a data science person, stop saying average. There's all different kind of means. The arithmetic mean is what you would think is average. So stop saying average. Okay, please. So that's the, I didn't run it. Stop. So the mean is 3, yeah. And the standard deviation is probably close to 1. I keep doing it. Sorry, one more and then we'll move on to the next one. So you can do a lot of statistics, and most people know what mean is, or mode, or standard deviation. So mean is one of the measures of centralness, or centrality, or that kind of stuff. And can you do other means? Yes, this is the arithmetic average if you don't do anything funky. Standard deviation. Did I get it right? I'm gonna try it. Oh, true. It's just, it's square root of 2, right? Yeah, I said 1. My mistake. So lovely. And what if it was 2 dimensions and 3 dimensions? These all still work. You can do the mean of a row, a column, any dimension you want, meaning axis. So not today. So we're going to do scikit-learn. And what's scikit-learn? There's scikit, and scikit has a few after the hyphen. It has a bunch of these things in the back. I'm not even going to tell you what they are, but scikit-learn is what we'll be dealing with in data science machine learning. Okay, so scikit-learn is the machine learning part. Now, does it have a lot of data science stuff in it? Yeah, depends what you consider data science. If I'm sitting there manipulating data and exploring the data and deleting rows and killing rows and graphing it and finding out it's not normal, then I have to scale it and all these transforms on it. You'll learn about it. It's Pandas. Well, that's like data science. That's not machine learning. So you'll learn a lot of things. It's everyone just says it's all the same. Not really. You can be really good at data science and be horrible at machine learning, or you can be good at data visualization and not know anything about machine learning. So, you might want to specialize. It's hard to know everything, especially initially. Okay, so don't panic if you don't know everything. You just, Okay, so this scikit-learn. So it's all about machine learning or modeling. Okay, so yeah, libraries focus on modeling. Yeah, that's true. Yeah, it doesn't. It even though it has capabilities of loading data and other things, it's not like its specialty. Okay, well, is it good at graphing? No, it's good at machine learning algorithms. Well, specifically machine learning algorithms. Okay, so it's good at fitting. So the big words are fit and predict. Okay, and we'll see hopefully some. So machine learning, you got to do all this stuff. But here we go. Wait. What is this? Well, wait. In Pandas, Pandas is very good at reading and manipulating data, and also writing this file out to any file format in the world that you know of, pretty much. It deals with Excel spreadsheets too, and you can read special, tabs within, your Excel spreadsheet has multiple pages. It knows how to deal with all that stuff. Just use Pandas to read it and get it in. Okay, so scikit. There's other ways you can get data. A lot of these packages will include like a data sets part. Now that's the word that scikit-learn uses. So does it have like standard data sets that are very popular? Yes. And when you first learn data science, machine learning, use the data sets that are seminal, like the classics. Okay. the tips database. You have tips for in terms of day of the week, how many people in your party, smoke or non-smoke, all that stuff, and how much you tip, and evaluate that. There's a tips database. There's the Titanic, data set, and you can slice and dice by lots of things. Ages, your cabin, where you're first class, second class, third class, that kind of stuff. How much you paid for your ticket? Did that help? That kind of. Or iris data sets, and there's tons of them. Okay, so here they are. So you're gonna say, hey, Scikit Learn, let me look at your data sets. Well, no, you're gonna specifically say, give me one of them. You're not going to get 7. Say it supports 20 data sets. Instead of you going around the internet and finding it, we'll go and get a URL from it. Like it has clean data on those data sets. So what else can you do? Well, the classic thing you do in machine learning is, I got a model. I got some numbers. Okay, the next logical question is, well, how good is it? Yeah, that's metrics. So metrics is just a number that measures something. Well, with the S, it's like, well, more than one way to measure it. Like, is it accuracy? Accuracy isn't always the best answer. So there's a lot of ways to measure how good your model is. So you want to evaluate your model. You can get your model. It can be a piece of junk. It's like, but look, it's a model. It's useless. Just because you can do something doesn't mean it's good or worth using. So you got to measure its performance, and that's the metrics piece of Scikit-Learn. And this is SVM. So real quick, you'll learn there's a lot of machine learning algorithms. You got to use the right machine learning. Okay, you got to use the right set of machine learning algorithms for whatever your problem is. So there's basically 3 breakdowns. Supervised learning, that's when you know what you're trying to predict, and they give it to you. You're trying to predict if you have cancer or not. Hey, let me look at data. Ooh, there's a column that says you have cancer or not. Yes, no. Ooh, that's I'm going to say that's supervised learning. Supervised learning, you're trying to predict something and you have it. So that's your target variable. You're trying to predict if you have cancer or not. And it's not just a binary thing. It could be lots of things. You're telling me you're trying to predict something. And you gave it to me. You gave me a bunch of test data that said, based on these numbers, cancer. Based on these things, no cancer. Based on these, and you have truckloads of these, and say, wow, can I make sense out of this? It would be cool. If you can accurately predict if you have cancer with like 97% accuracy. It's like, you can do that? Yeah, I'm going to ask you 10 questions. And based on that, I'm going to tell you, there's a good chance you have cancer. We're going to check you out. We're saying you're a high likelihood person that's going to have cancer. We're going to call you in and do some tests to, really do it. That kind of stuff. And is there a chance of missing people? Yeah, that's bad. What if you had 3%? Wait, I have cancer and you told me I did. Oh, not good. So now, so they supervise. What about unsupervised? I don't know what I'm trying to predict. Here's a bunch of data. Can you make sense out of this? And there's the other one, reinforcement learning. So that's like, when you're learning about, hot flames when you're a kid, or, when you're riding a bicycle, you learn how to get it. And then after a while, you say, this is good. I'm not going to do that anymore. That makes me crash. Oh, look, if I keep doing this, I stay upright longer. So you reinforce the good things and you sort of depress the things that are bad. So there's positive, it's rewards, and it's also all these terms. So there's good things and bad things. So that's the third one. Supervised, you know what you're trying to predict. Unsupervised, you don't know what you're, you don't got any variable labeled as target. I'm trying to predict something. They say, here's the data, make sense out of it. Good luck, that kind of stuff. And the other one is reinforcement. It's how you learn, like, glowing, flickering, red, yellow, blue equals heat equal melting finger. Kids learn that. Oh, if I go here, this hurts like hell, and it hurts like for 3 days. And you keep doing this stuff. Every time using glowing red things, avoid those. They're dangerous. One of those. And yeah, most kids learn that way. You don't sit there and teach them everything. You don't sit them in a chair and say, this is good, this is bad. This is, they learn by exploring. And that's definitely how they learn the language. You don't sit there and teach them a language, but somehow miraculously they learn how to speak. It's reinforcement, right? Right. So we're going to use support vector machine. So that's just one machine learning algorithm. Okay, and this is the C. It's one piece, so it's categorical. So leave that alone. So it's supervised. So you better have some data, and one of the columns or more, usually it's one column, tells you what you're trying to predict. Based on these inputs, they had cancer. Based on these inputs, they didn't have cancer. And there's truckloads of these, observations or records. Lots of them. More data, the better, usually. Oh, the more good data. I can give you a bunch of junky data. Or the classic is, what's better than 10 records? I'll just duplicate them. Oh, now you have 20. No, duplicate records don't tell me anything more. It doesn't tell me it doesn't help me. It's no more informational content than I already have. I already have that record. Stop giving it to me more than once. And people are like, well, it's 20 records, but they're repetitious. So you'll look for repetition, and that kind of stuff. So here we are. So, by the way, we got to run this thing. We didn't run it. So if we ran this cell, just to show you, it'll say, I don't know what a data set is. Right. Yeah. Name error. Right. Yeah. Okay. So here we go. We say, hey, scikit learn. By the way, you don't ever want to do an import scikit learn. It's huge. So when you do this, you say, there's this huge thing out there called scikit learn. There it is out there. From that scikit learn, I only want the data sets. Well, I want access to be able to call the data sets. You didn't load any data set yet. Well, also, the scikit-learn has a way to measure machine learning model algorithms in the sense of performance. Okay, give me that metrics piece of that big monster thing called scikit-learn. Well, you say, you can do, and here's one saying, the scikit-learn has an SVM part, but that SVM part is still even big. I only want the SVC part of it. And you say, wait, notice this capital. That's a class. That's a class. It's an object. These are not. These are packages or modules. So here we go. Just pay attention to the uppercase, lowercase thing. So support vector machines. So you can read all about support vector machines, but this is for the C is for classification. Well, you say, what's the difference? Classification says, should I go north or south? It's not a number. Oh, well, what if I want to go north, south, east, west? That's still classification, but there's 4 outcomes. There's 4 possible classes you can pick. Well, cancer or not, that's classification. You do, not you, but the data. That one is one of 2 classes. You have cancer, you don't. That kind of stuff. That's called classification. But the opposite of classification is regression, and regression is continuous data. So you're going to say, I'm gonna accurately predict your body mass index. So that's numbers, I don't know, 15 to 25 or something, somewhere around there. And based on your this and this and this, I'm gonna ask you like 5 questions based on your physical body and your lifestyle and other things, and I'm gonna reliably predict your BMI. Well, that's without even touching you. It's like, whoa, you can do that? Well, it's not as good as the real thing, like really measuring you, because I'll say I'm going to look at these things and predict the BMI, and can I do that? Sure. Well, I want to compare the BMIs of all the countries. Well, a chance of you measuring the BMI of all of the, but I got those other 5 questions from everyone. I know their weight, their height, their age, I can theoretically predict their BMI. Is there a trend in BMIs on different? Is Europe worse than us, or South America the best? That kind of stuff. Or by country, maybe because of their diet or something. Who knows? But you don't have the BMI. So but the BMI is a real number. It's not a real number. It's like a floating point number. It'll be like 23.7. You're worse off than me because I have a 22.1. That kind of stuff. Okay. So BMI, body mass index. So that's so here it is. Load. So classification is you have 2 or 3 or 4 outputs. It's one of those. Regression is a continuous number. It's not discrete. I have 23.73 body mass index. You have 23.71. Oh, we're off by like 2 100ths of them. Yeah, but they're not categories. They're continuous. Okay. So here we go. Load iris data set. Okay. Of course, did I run this? Yeah. Oh, I didn't run it, so I don't want to do it again. I'm going to run this so it knows about data sets and the metrics and SVC after you run this cell. Oh, by the way, the first time you import it, it takes some time. Okay, so if I run it again, it's fast as heck. Well, wait, how did it load it so much faster? Well, I'm gonna run it again. The first time it's slow, it's cached. Take the Python data science course. I'm sorry, Python for data science course, and we'll learn about this. And we'll write our own one of these where you can import from the thing you wrote. You can say, and I wrote one called import edutils. So if you ever see that, that's me. But import edutils, and it has utilities to help you explore Python. Okay.
A quick question: do we need to import this every time we run the Python, or is it just a one-time thing?
No, if you're not doing any machine learning, I don't need any of this. I hate double negatives. You might need this if you're doing machine learning. Yeah, this is machine learning now. Scikit-learn. We're talking about Scikit-learn package or library. It's a package. It's a package. So there is a difference between a package and a library and a module. Leave it alone. Take the Python for data science course. We write our own. And so this is all about Scikit-learn. Remember, this is our third or fourth library. So this is all about machine learning. Well, how many algorithms do you have? We ain't talking about anything except supervised learning. Well, how many supervised learning algorithms are there? 10, I would say 10 or so popular ones. Well, it's supervised learning. Shouldn't we use the unsupervised learning? Go ahead and waste your time. It's useless. It's pointless, fruitless, all this stuff. Well, I have some reinforcement learning algorithms I can throw at this. It's not reinforcement learning. So, but look, I have 100 algorithms. Why don't I just throw 100 algorithms all the time? It's like, because 70 of them are useless. I mean, this is a supervised learning problem. Okay? And specifically, it's a classification. Oh, irises. You're trying to predict what kind of iris it is. And there's only three. Well, long story short, this is a classic data set. So you learn it. Based on some numbers, I'm going to tell you which iris it is. There's only three different kinds of irises, three varieties or species of iris. And I'm going to be able to tell you it's this one, or this one. Virginica, Setosa, and something else. They're the varieties of irises. Based on like 4 measurements of the flower, I can tell you what species it is with insanely high accuracy. So here it is. But this is a classification problem. There's only 3 different kinds of irises, species. Okay? The color doesn't matter. It's the size of the flower. Okay, petals and sepals. It's a bio thing. So one of the leaves go down, one of the leaves go up. And the proportions of them tell you a lot. So of what type of species. So I'm going to load a data set. And it's called DS. Well, wait, what is this? What is this DS thing? Wait, this is Scikit-learn. It's Scikit-learn is loading the iris data set. What is this DS thing? And you want to do this really quick. And I'll say give me the type of DS. Oh, it's a bunch. And it's a capital B. Oh, it's a class. Yeah. Okay. Enough of that. So you want to do some things like this. Hey, DS. Remember, it's DS. Okay, DS. You can call it anything you want. Most people don't even talk about the bunch thing, but okay, we'll just say ds.shape. Wait, I thought shape was a pandas thing. Oh, it can't do shape. Okay. And it can't do that. So the question is, can I do is it DS? Wait. Wait, let me see this. I'm trying to figure out how to do this. Oh, wait. This is Scikit-learn. Okay, hold on. I'm just going to do DS. And see, what is this stuff? Well, it looks like wait. Braces. That brace there. Oh, man, it's a dictionary. It has a data key, which looks like data. Okay, it has a data key. Then it has, oh my goodness. Luckily, there's only 150 rows, I think. Okay, then it has a target thing. Well, this is the target. Wait. Target or labeled variable is almost a sign that it's almost surely supervised learning. So you're saying There's a lot of zeros, there's a lot of ones, and there's a lot of twos. Wait, there's 3 different kind of things. Oh, this almost looks like classification. It's trying to target or predict these things. Well, this is not predicting anything. This is just data. It's not predicting anything. This is just raw data. Okay, so it has a target. So these measurements, if you ask for those 4 measurements of the flower and you got something like that, it would say it's iris number 2, iris variety species number 2. Okay, and what are the names? Well, that's target. They say we're going to give you a frame too. Don't worry about frame, but we're going to give you the names. Well, wait. 0 is Setosa. The 0 is 1 is a versicolor. I don't know which one I missed. The second one is Virginica. So this 2 is a Virginica. So if you have numbers like near this, it's going to say with high accuracy, it looks like a Virginica. Pretty cool. Okay, lovely. And it also has description. So this is more like a data dictionary kind of thingy. You can print it out. You would say print of it because you can see a lot of these things. This will be readable if you do a print of it. Okay, and it tells you some neat things, and it looks really hard to read, but if you printed that. So wait, this is a dictionary. So okay, it's a DS. It's a dictionary. I know it's a dictionary. It sure looks like a dictionary. I'm going to go with what I know about dictionaries. I'm going to say, give me the keys. Uh-oh. And I'm going to hit run. Well, shift run. Oh, I said keys. Duh. And there they are. Data, target, frame, and we've seen them. Oh, well, we didn't catch out the feature. So you say, well, this is weird. So when you import data from places, you got to ask, does it have the columns? Does it not have the columns? Does it have the target? Do I have the target name? Do I have the target thing? Do I have this? Do I have this? Well, Sidekick Learn goes through the trouble, and it slices and dices this all for you. And it puts it into it. You want the data? Go to data piece. If you want the target, meaning the 0, 1, 2s, go to the target. If you want the whatever a 0 and a 1 and a 2 means, go to the target names. So, for example, and then we'll look at it. So you say, hey, DS dot, and this is just like you dealt with pandas. Keys are put, by the way, these are dictionaries. Okay? So you do this format. This is the way, you say pandas does it. No, pandas does it 2 ways. This is the dictionary version of it. And it came from this. This came first. Dictionaries came first. It's Python thing. So I'm going to look at I'm going to look at something really simple because it'll be really simple. Where's target? Target names. Oh, I guess I should put them in quotes. Target dash target. Names. There it is. And I'm going to print it out. And there should be like 3 of them. Virginica, then the order matters, but yeah, there they are. Okay. So if I want the data, I say DS, and remember. You can also do this, especially if you go to another language, you can do this. Well, in fact, other languages force you to do this, but Python lets you do everything. Well, almost everything. You say, well, which one do you like? No, this doesn't have any spaces in it, so I can do either. And they specifically did not put spaces. It's not file space name. So you can do both things. Scikit-learn came late, so they did things like to make your life easy. So here it is. I got a bunch of data. Where's my data? There it is. .data. So I'm going to say ds.data. Now I can actually do the square bracket thing too. I'm going to say shape. 150 by 4-ish? 5-ish? I forget. Oh, DS.
DS.
Yeah, I know. I sit behind too many keyboards. Tuple is not callable. Yes. And by the way, when you do print, and just stop memorizing this stuff. I do this often, and it's not a method. You can't run it. Meaning a method is callable. So are functions. And there's other methods you can say is callable. Like, oh, that's kind of cool. So here it is. It's the data. So if you looked at the data, there it is. There's the 4, and there's a bunch of them, and there's 150 of these. Okay, 150 rows or observations or records. So the next question is when you deal with data science and you're trying to do machine learning, it's like, well, are they equally distributed? I have 3 different kind of things. I have 150 of them. is 140 of them setosis. That's called imbalanced data. Just stop. It's useless. Oh, can I run through a model? Sure, it's useless. It's heavily biased towards setosis. I have 140 setoses and 5 versicolors and 5 virginicas. It's heavily biased. You got to make these roughly uniform. You know, like with 150, it's 50 of these, 50 of them, and I'm going to tell you it is, and you know, so it is balanced. It's actually perfectly balanced. So there's 50 of each variety. Where's its species? I forget. Anyway, so here we go. So I know it's classification. I want to be able to say 0, 1, or 2, meaning Setosa, versicolor, virginica, that order, SVR. Okay, they're alphabetical in this data set. Okay, so you say, hey, SVC, what's that? You're saying, hey, scikit-learn, you told me I can have this support vector machine specifically for classification. This is classification problem. It's one of 3. It's not continuous. So you want to go with anything that sounds like it's classification. So yeah, and here it is. So it's this camel case, and so this is constructing okay, it's initializing a model, the SVC one specifically. And you know, because we're not cool, we'll just call it model. If you have lots of models, you don't want to call it model 1, model 2. You'll name them something useful. Like, because this is classification, I'm going to try all classification models I know of. Well, this is only one of them. Well, remember, this is only one. It's an intro, right? So you're going to say, here's a model, and it's SVC, support vector classification. It's for classification. Okay, lovely. I stamped out an object. I decided to assign it to the word model, variable, model. Okay, what do I do next? The classic thing you do with scikit-learn, it follows the same format. You, at least with supervised learning, you say, give me one of those models. There's truckloads of these. Okay, find one and measure its metric. And then you'll say, try another one, measure its metric. Find another one, measure its metrics. And you say, oh, this one's so much better. So you try a bunch of models that are appropriate. So this is a classification problem. We're only going to do one now. Here we go. Stamp out a model. Then what you do is next thing you do is you say, I got one of those models. Good. You fit the data. So you give it the X's and you give it the Y. Okay? These X's have a bunch of them. There's 150 of them in sets of 4. I'm going to give you 4 numbers, and I'm going to tell you that was 0. I'm going to give you 4, and that was a 0. I'm going to give you 4 more, and that's a 1. And it will fit the data based on those 4 X's. So you can't graph 4 X's. You can't want to, like, visually. Just think about graphing. I can graph this and see if there's a 4-axis graph. And where do you put that 5th one? It's mind-boggling. So you just let the math do it. Well, what if you only had 2 X's, only 1 X and 1 Y? Yeah, you can graph it. You only have 1 X. The X is on the horizontal. That's the independent axis. And it will be, the Y is dependent axis. Based on this X, I will produce a Y. I can graph that. It's only 2 dimension. Can you do 3 dimension? Yeah, I have an X and an X, and it produces a Y. Okay. 4 dimensions.
Unmuted.
6 dimensions. It's like, how do you draw that? I mean, no, you don't manually draw it, okay? So it's coming in with 4, and it's a 0, 1, or 2. 4 more, and it goes through all 150 of them. Okay, lovely. It comes out with a fit. Okay, it inside this model object is a bunch of stuff, including the weights of the model. And we'll stop after this model, okay? So Mo's listening for the next class. Here we go. So model is SVC. Well, what's behind the scenes? It's fitted. Your model is fitted to this data. Well, okay, wait. I get the data. Okay, got it. I asked for a model. Okay, got it. I got a model. Nothing yelled, and it said, you know that model. You fit it to your data. So you get the model. You fit the data. Wait, you fit the model to the data. Got it. So model is inside of model. That's an object. It has a bunch of things. It's all tuned to ready to go. And what do you do next? You say predict. So the big view of life is get the model, fit it, predict it. Now, what do you predict? Well, here it is. Well, wait, here's the target. Okay, we're saying that's what's expected or predicted. A lot of people will say predicted. So here is what you expected. What's the same as the target? Yeah, I got those. There's 150 zeros and ones and twos. Got it. Well, we're saying, no. I got that. That's the real data. Zeros, ones, and twos. What I'm doing is saying, hey, model, I'm going to give you the data. I'm not showing you what the output should be. I want you to predict what the output should be. And it's going to do, 4 numbers. It's going to say, that looks like a 0. 4 numbers, that looks like a 2. 4 numbers, that looks like a 1. So it's going to predict a bunch of 0s and 1s and 2s. Wait, so here's a bunch of 0s and 1s and 2s, 150 of them. And here's a bunch of 0s and 1s and 2s. It's going to, and you're saying, is every one of these expected the same as every one of these predicted? I find that hard to believe, but I want it to be really high. Like if you said, the 50th, if you look at the 150 numbers, say, look at the 50th flower, iris. What was it really? Shh, be quiet. Don't tell the model. It looks like a number 1. It looks like that iris type 1. Okay. Give the predictor model those 4 numbers for the 50th element, and it said it was a 1. Yes, that's a good one. That's called a true positive. My model truly predicted it as positive. Well, what else can you get? Well, I said it was a 2 and you said it was a 1. That's false. So that your model was off. So now we can talk all about that, but I'm just going to talk really quick. Well, what do? You say, I got 150 012s and 150 012s. Model predicted it. Okay, so I'm going to look at the metrics, and I'm going to throw in 2 things. I'm going to show you what is reality, expected, versus predicted. So you'll hear these words called Y and Y pred. If you ever hear Y pred, it's this one, predicted. And you're trying to compare them 1 for 1, and it's going to come out with a report. Okay, and the big one is accuracy, 97%. We can explain all these other ones, but not today. 97% accuracy? That is insanely good. That's crazy good. Wait, so it's off. Well, it's 150, so I can't do the math easy. So if you gave me 1,000 data sets, 1,000 different records of flowers, I would get 970 of them right. That's crazy good, right? And it's based on the measurements of. It's based on the measurements of 4 measurements of the length of the sepals and the petals.
Hey Ed, sorry for interrupting. Yeah, we gotta stop here. Unfortunately, we could continue probably tomorrow, or we could do it other day, but we gotta stop because we have to jump into another class. Unfortunately, everybody, sorry for that. So tomorrow we are going to have a session at 10 a.m. From 10 a.m. to 12. So we could continue for tomorrow, or we could jump into different session. But that's it for today. I'll talk to you guys tomorrow. Until then, you guys have a great rest of the day, and bye everybody. Thank you, Ed.
Mo, you want to create a video for this and save it, or me?
Yes, I have it. Don't worry, I have it.
Okay, folks. We'll see you tomorrow at 10 to 12.
Thank you. Bye, everybody.
Thank you.
Bye.
Bye.
Thank you.